So this is question number 11, which is also based on Lagrangian. So the Lagrangian for a particle of mass m in an electromagnetic field is given by. So this is the Lagrangian. The Lagrangian they only given. Okay. So this is for kinetic energy and this is for potential energy. So this is the Lagrangian if a particle in electromagnetic field, right? So let us, that means if there is a charge particle, if this charge particle is placed in an electromagnetic field, so its Lagrangian is this one, and this is the kinetic energy of this particle and this is the potential energy of this particle. Now we should calculate the momentum conjugate of this Lagrangian along x. Momentum conjugate along x. See, the momentum conjugate is along x is px is equal to dou L by dou x dot. So which is equal to, what is L here, of m x dot square plus y dot square plus z dot square minus q phi. So this phi is scalar potential of x comma y comma z of t plus q of a of x comma y comma z of t, and this a is vector potential and this phi is scalar potential dot v. Velocity one more is here, that velocity is also time dependent. So dou L by dou x dot is equal to, if we differentiate this, we will get, while differentiating x, all other y and z are constants. So it has m x dot, and also we have a x comma y comma z t dot v. V is nothing but what? V is also nothing but x dot plus y dot plus z dot. Now we should differentiate that also with respect to x dot. So then it is plus, the coefficient is q of a, right? Q into a. So therefore px is nothing but m x dot plus q into a. Is there any option? M x dot plus q ax. So option C is correct. So this is the momentum conjugate for this charge particle when the charge particle is placed in an external electromagnetic field. So this is question number 13. Let E and P be the energy and momentum of a relativistic particle with rest mass m. That means a particle is moving with a velocity of light approximately equal to the velocity of light. So then what is its total energy? So that is E square is equal to P square C square plus m naught square C power 4, and E square is equal to P square C square minus m naught square C power 4, and E square is equal to m square C power 4 minus P square C square, and this is. So by seeing these equations we can easily answer that. We know that E square is equal to P square C square plus m naught square C power 4 is the energy expression for a particle which is moving with a velocity of light. Next question is, rotation of a vector in a xy plane about a z-axis is represented by a 2 cross 2 rotational matrix. So 2 cross 2 rotational matrix we should construct, and what is the trace of that matrix? We should also calculate the trace of that matrix, and we should choose which one is the correct in this 4 option. So here they are given xy plane about the z-axis, a particle is rotating. That means z-axis is constant. So let us consider x plane and y plane. So this is old coordinate. In this old coordinate there is a particle. Now it is rotating. So that means the coordinate is rotating. That means now x is changes to, which makes some angle theta, and it is x prime, the new coordinate, and y is changes and which makes some angle theta, and this is y prime. X to x prime, y to y prime. it is rotating. And now we should calculate the rotation matrix, the elements which is coming, the magnitude and vector which is changing of this vector. So now that is the new coordinate x prime is equal to x cos theta plus y sin theta, and y prime is equal to minus of x sin theta plus y cos theta. If we construct this, so x prime y prime which is equal to cos theta sin theta and minus sin theta cos theta into xy. So this is the matrix. Okay, so that is just like x prime is equal to rz into x. So this rz is the matrix. So rz is equal to cos theta sin theta and minus sin theta cos theta. So what is trace? Trace is nothing but sum of the diagonal elements of the matrix. So that is, if you add these two matrices, so this is trace, diagonal elements, cos theta plus cos theta, 2 cos theta. So answer is 2 cos theta. So option D is correct. So this is the question number 15. If the orbit of a body is given in a polar coordinates r theta is equal to constant, it is under the influence of force that varies as, so these are the 4 options given. Okay, so let's see. So let us consider the given is r theta is equal to constant, and that constant I am considering as some c. Okay, so now this implies r is equal to c by theta, then 1 by r, see, 1 by r is equal to theta by c, theta by c. Now let us consider that 1 by r is equal to u, then 1 by u is nothing but r, but we have an expression that is f of 1 by u into divided by j square u square minus mu is equal to u plus d square u by d theta square. So therefore let us differentiate u with respect to theta. Okay, so sorry, there theta by c is nothing but u. Let us consider theta by c. So let us consider theta by c. Okay, let us consider 1 by r is equal to u, and so 1 by r is u. So therefore u is equal to c by theta. Now differentiate this, so du with respect to theta, d theta, so which gives c, and again differentiate this with respect to theta, so it will be 0. So therefore d square u by d theta square is 0, and this equation becomes, so therefore write f of 1 by u is nothing but r into minus mu divided by j square into, see, this is u square. So what is u? U is nothing but 1 by r. So therefore, so write as it is, u in is equal to u plus 0. So now after simplification, C. We will get, so f of r is equal to j square u cube divided by mu. So f of r is equal to this constant into u cube. So what is u? U is nothing but 1 by r. So f of r is equal to minus of that constant into 1 by r cube. So therefore option C is correct.